Hi guys, come back to question number 8. Okay, question number 8. Figure shows two vectors A and B whose magnitudes are 6.8 and 5.5. So determine C if C is equal to A plus B. Okay, so first we are looking at the vector given pointing in the opposite direction. So this is our vector A. Okay, our vector A is 6.8. Okay, 6.8. And then the next one is our vector B. Okay, vector B is shorter. This one is 5.5 units. So that means this one is positive, this one is negative. So we draw that vector in a IJ format first. Our A is positive 6.8 I units, alright? And then our B will be negative 5.5 I units also. Okay, units. This one also units, alright? So now if C, okay, is equal to A plus B. Okay, if C is equal to A plus B, we just do in using a vector component. Our A is 6.8 positive plus negative 5.5 I. So what do we get? 6.8 minus 5.5, you're going to get 1.3. Okay, 1.3 I units. Okay, units. So that is our vector. What is the direction? So the magnitude, if you look at the magnitude, is 1.3, right? Units. And then the direction, okay, direction of our C is positive x direction because it's positive I. Okay, positive I. Okay, next one. Okay, next one, B. B is C is equal to A minus B. Okay, A minus B. So we put in A 6.8 I minus okay, minus 5 negative 5.5 I. So minus means plus. So plus we're gonna have this 12.3 I units. Okay, 12.3 I units. Alright. So the magnitude is equal to 12.3 units. And the direction of the C is positive x again. Okay, positive x again. So now our C, the third one is B minus A. Okay, B minus A. So B is negative 5.5 I minus 6.8 I. Definitely you want to get negative 12.3 I units. Okay. So our magnitude is the same as before, 12.3 units, but the direction now is negative I, which is negative x direction. Okay, so these are the information that you can get by using component method. Alright, so that's it for question number 8. Okay, it's quite easy because it's only one horizontal direction only. Okay. Okay, next one is number 9. Okay, question number 9. Okay, so an airplane is traveling 635 km per hour in a direction 41.5 degree west side of the north. Okay, you can refer to the diagram here. Okay. So that one is west side, 41.5 degree west side of the north. Find the component of the velocity vector in the northerly and the westernly. Okay, so meaning that you're going to find the component of this one regarding to the north, and this component is the same like you assume this one is a x, this one is a y. So you're finding the horizontal component and the vertical component. So we will do it using our own diagram here. We draw another diagram for that. Okay, so this is our north, we assume is our y, and this is our east, we assume is our x. So that means the other side, west, is the negative x. So our vector is here. This is our vector here. It is the velocity of the aeroplane. V is 635 kilometer per hour. All right, and at an angle theta equal to 41.5 degree. So now we're going to split this vector into two components. Okay, so one of these is horizontal, another one is vertical. All right, the horizontal one is our Vx and the vertical is our Vy. Okay, Vx and Vy. So our angle 41.5. So this is our northerly component. Okay, northerly. This one is the westerly direction. All right. So we find a component just like we do in normal one, but if you look at the angle carefully, this one theta is with the vertical. We want to use this theta, alpha. Okay. So we know that alpha is equal to 90 minus theta. So we're going to get 48.5. Okay. Our angle with a horizontal line, because our formula is based on the angle with the horizontal line. So alpha is 48.5. So that when you sum up with this one, you get 90 degrees. So our Vx is equal to the V cosine theta. So that one will be 635 kilometer per hour cosine 48. Sorry, not theta here. Alpha. My mistake. Cosine alpha. So 48.5 degree. So 635 multiply cosine 48.5, so we get 421 kilometer per hour. Okay, kilometer per hour, but negative, huh? But we don't use negative here because we are using west. Okay, we're using west. Next one is our Vy. That one is a V sine alpha. So it's 635 sine 48.5 degree. Let's see what do we get here. 635 multiply sine 48.5. Okay, so now is 476 kilometer per hour. Every hour travel that many kilometer northerly and westerly. Okay, so there is A, first part. And then B. How far north and how far west has a plane travel after 3 hours? So we calculate how far it moved after 3 hours. In the western direction, we call it SX. Okay, and this one will be SY. Okay, SY. So now this one is 3 hours, so you're using Vx multiplied by time. This one will be Vy multiplied by time. So this one will be 421 multiplied by 3 hours, and that one will give you 421 times 3. It's going to give you 1,263 kilometer. That is how far from the original position. And then this one here is 476 multiplied by 3. 476 times 3, you get 1,428 kilometer. Okay, so that is in component method. Okay, so that means when the plane is continue on for 3 hours, it will be somewhere around here. So how far from here vertically and how far horizontally from here, that is the distance. Okay, so for question number 9. All right, it's a bit difficult for this one. Next one, number 10. So number 10, let's assume V1 is negative 6.0i plus 8.0j, and your V2 is 4.5i minus 5.0j. Determine the magnitude and direction of V1. Well, that is easy. So we have number 1, the magnitude of V1 is the square root of each component square. Okay, so negative 6.0 square plus 8.0 square. So that one will give us 6 square plus 8 square, that is about, I think, 10. Okay, 10 10 units. Okay, 10 units. Okay, 10 units, and the direction will be we have to calculate using tangent. Okay, using tangent. So this thing, we draw the vector first before we. So this vector is negative 6. Okay, negative 6 going to the left hand side. Okay, so negative 6 here. And then you have another vector which is positive 8. Okay, this one is positive 8.0 j. So this is actually your V1. Okay, that is your V1. There is your V1, and the angle is here. I call this one theta. Okay, so you can use tangent. Okay, tangent theta is equal to 8.0 divided by negative 6. So let's see what do we get here. So we have arctangent 8 divided by negative 6. So negative 53.1. Okay, negative 53.1 degree. Alright. So there is an angle negative 51.3. That means negative because you are measuring angle from the horizontal up, going up clockwise into the surface area, negative. Alright, with diagram, you don't actually have to define the meaning of negative sign. Next one, B. Our B is V2. Okay, so the magnitude of our V2 is the same, square root 4.5 square plus negative 5.0 square. And this is what we get, 4.5 square plus 5 square, and then square root everything, we get 6.73. Okay, 6.7 units. Okay, 6.7 units. And then this vector here is horizontally positive and negative now. Okay, so this is our vector 4.5i, and then negative down here. This one is negative 5.0 j. So when we sum up this, we get this vector here, and the angle here I call alpha. Okay, alpha. This is vector V2. So using tangent. Okay, tangent alpha is equal to this, negative 5.0 divided by 4.5. So alpha is arctangent negative 5 divided by 4.5. Alright, so get negative 48.0 degree. Okay, negative 48.0 degree. Negative again, you measure from the horizontal line down. Okay, again clockwise, negative. Alright, so that is B. Next one, our C. 10C is V1 plus V2. Okay, our V1 and V2 are these two. We sum them up, see what do we get. So we write down negative 6.0i plus 8.0j plus the next vector 4.5i minus 5.0j. Okay, negative 6 plus 4.5, you're going to get negative 1.5i. Okay, negative 1.5i. And then at j minus 5, you're going to get 3.0j units. Okay, units. That is our resultant vector. So now we calculate the magnitude and also the direction. But first we draw this vector first. You can calculate like the one before, but I can draw this vector first. Negative 1.5 Negative 1.5 is here. Okay, so negative 1.5i, and then this one is positive 3.0j. So when you combine that two, you get v1 plus v2. So this vector is v1 plus v2. And the angle here, I will call it something else, alpha, theta, beta. Okay, beta. So our magnitude is the same square root, this one, negative 1.5 square plus 3.0 square. Okay, let's see what we get here. 1.5 square plus 3 square, square root everything. Okay, we got 3.4 units. Okay, 3.4 units for the magnitude. And direction, same thing, we're using tangent. Beta is equal to 3.0 divided by 1.5 negative. So our answer will be also negative lah. So arctangent 3 divided by 1.5. So it should be negative 63.4. Okay, 63.4 degree. And then D, next one, that is V2 minus V1. This is V2. So write down that 4.5i minus 5.0j. This is our V2 minus our V1. Negative 6i plus 8.0j. Okay, so we minus, we got 10 plus 10.5i. This one minus become negative 13.0j units. Okay, then we draw this vector. The first one is 10.5i. Next one is negative 13 here, negative 13.0j. So we now combine that two, we get this vector v2 minus v1. Okay, v2 minus v1, and this angle we call something else, gamma. Okay, we call it gamma. So we calculate magnitude v2 minus v1 is equal to the square root. Okay, 10.5 square and then plus negative 13.0 square. Okay, 10.5 square plus 13 square, square root everything, get 16.7 units. Okay, 16.7 units. And direction, tangent again, tangent gamma is equal to this one, negative 13.0 divided by 10.5. So our gamma will be arctangent negative 13 divided by 10.5. Okay, negative 51.1 degree. Right? So that's it. That is the question number 10. This is quite difficult. Long question. Okay, it's a long question. Okay. 11. Okay, question 11. Okay, question 11a. Determine the magnitude and direction of the sum of the three vector. Okay, you are given vector v1 is 4i minus 8j, and then v2 is I plus j, and then v3 is negative 2i plus 4j. Okay, now sum up. Number one is magnitude and direction of the sum. So our first one is sum. So that is v1 plus v2 plus v3. So that means you have 4i minus 8j plus I plus j and plus negative 2I plus 4j. Okay, so 4 plus 1 5 minus 2 3I 3I left, negative 8 plus 1 negative 7, negative 7 plus 1 again, that will be, oh sorry, plus 4, negative 8 plus 1 negative 7 plus 4 negative 3. Okay, units. Alright, so we are going to calculate the magnitude and direction. So we draw this vector. Okay, we draw this vector. We've got positive and negative. This is 3I and the negative here is negative 3j. So this one angle is very easy because both components are the same magnitude. So I call this one alpha. So this is our vector v1 plus v2 plus v3. This one, eh? Okay, our magnitude. So I will call this vector v lah. So our magnitude v is equal to the square root of negative 3 square plus 3 square. So we're going to get what? Square root of 18. Okay, square root of 18. So get 4.2 units. Okay, 4.2 units. And alpha is 45 degree negative. Okay, negative. So that's it. That is the first one. Okay, for the 11A. Okay, 11B. 11B, the question wants this. V1 minus V2 plus V3. Okay, so I put in the value. This one is 4I minus 8j minus I plus j, and then plus the next one is negative 2I plus 4j. Okay, 4 minus 1, 3 minus 2, 1 left. Negative 8 minus 1, negative 9, negative 9 plus 4, negative 5. Okay, units. So that's what we get. Then we can draw this vector. Horizontally is 1 I. Vertically down, that is negative 5j. Okay, so we combine them, we get this vector. This vector is your v1 minus v2 plus v3, and we call this one v. Okay, v. So our v, magnitude of our v is the same square root 1 square and then plus negative 5 square. See what do we get? 1 plus 25 square root 26, 5.1 units. Okay, 5.1 units. Next one, tangent theta. Our tangent theta is equal to negative 5 divided by 1. So our theta will be arctangent of negative 5. Okay, so negative 78.7 degree. Alright, so that is our question number 11. Okay.